Good morning everyone, I'm MAZLAN and today we'll explore how volumetric analysis, specifically titration, helps us measure acidity and pH in food and beverages. We'll see why these measurements are crucial for flavor, safety and quality control. Acidity control is vital. A low pH environment prevents yeast, mold and bacteria from growing, meaning a longer shelf life for the products in the industry. And since regulation mandates specific acid levels on labels, titration especially ensures that this industry meets those legal requirements every batch. And what this means in legal terms is regulatory compliance. On this slide, we can see that acidity control, in practice, we will pipette a known volume of food or beverage into a flask, titrate it with sodium hydroxide, for example, and note the exact point of neutralization, either by watching for a pink color or reading the pH. The pink color here means or indicator a pH meter known as phenolphthalein. That volume tells us the total acidity, which is the endpoint of titration indicates the volume of base. Here we can see the common food examples that we can test on. For vinegar, too little acid risks spoilage in usage, especially when we are making food that uses vinegar. Less vinegar means risk spoilage, and it upsets the flavor or it may fail the regulation as stated before. Juices rely on citric or malic acid for both sourness and microbial inhibition. That means it slows down or it stops the growth of microbials immediately. And in yogurt or cheese, lactic acid levels control how the product sets and tastes. This means that lactic acid in cheese or milk help the products to settle. Let's say the production of cheese, pH versus titratable acidity. We will multiply the molarity of our sodium hydroxide by the volume used to get millimoles of H+. That value combined with the acid molar mass at sample's weight or volume converts into a clear percent weight over volume table. Triplicate titration ensure our results are statistically sound. And more information on this, these buffering compounds can mask true acid load. This means that we may not be able to know the true acid load unless we remove the buffering compound. Now, for data and calculations. To calculate millimeter mole or millimole, we need H plus equal mole of sodium hydroxide times volume of sodium hydroxide in liters. Next, we need to convert the percent acid using molar mass and sample mass. And then we need to run, like before, in triplicate to produce a good reproducibility and to ensure regulatory compliance. In summary, volumetric acidity analysis underpins every stage of quality control, delivering consistent taste, proven safety, optimized shelf life, and data-driven process control. It also drives cost-effective production workflows, support research and development of new formulations, enhances supply chain transparency, and generates the audit-ready documentation required by regulators to ensure compliance and to maintain consumer trust. By providing this robust, reliable acidity profile, titration helps manufacturers respond quickly to quality deviation and to minimize waste and uphold strong brand integrity. I think that is all from me. Thank you.
Assalamualaikum and good day everyone. For the application section, I will explain the use of the burette in volumetric titration, which is a key technique in analytical chemistry. Titration is a process where a solution of known concentration, usually placed in a burette, is added slowly to another solution until a chemical reaction is complete. This is often used to determine the unknown concentration of a substance. The burette is used because it allows accurate and controlled measurement of the volume of liquid being delivered. It is graduated in milliliters and can be read to 2 decimal places, which is important in getting precise results. To use the burette properly, we first rinse it with the standard solution to avoid dilution error. Then we fill the burette, making sure no air bubbles are present in the nozzle. Initial volume is recorded by reading from the bottom of the meniscus at eye level. During the titration, the solution is added drop by drop until the color change occurs. The final volume is recorded and the volume used is calculated. The accuracy of titration depends heavily on the correct use of glassware like the burette. A small error in reading the volume or improper handling can lead to wrong concentration calculation, affecting the validity of the analysis. That's why the burette is considered an essential tool in analytical chemistry. That's all from me. Thank you.
Okay, now I'm going to tell you guys about reducing sugar determination. Alright, in determination of reducing sugar, like glucose and fructose, it relies heavily on precise measurement, control heating, and optical density reading. Special glassware like beaker, flask, burette, and crucible are often used for different stages for process. Alright, now we will discuss on how this amount of sugar is calculated. First of all, reducing sugar have this kind of free aldehyde or ketone group that can donate electron and reduce other compound. In food chemistry, we often use valine or Benedict solution, both of which contain copper to ion. When reducing sugar is present, it reduces the blue copper ion into red copper oxide, forming a precipitate. The amount of sugar is calculated based on how much the copper solution is reacted and how much the precipitate they present. Alright, now we move on to the sample preparation. Non-reducing sugar, like sucrose, must first be hydrolyzed into glucose and fructose using diluted acid before analysis. This is because they lack a free aldehyde or ketone group that can react with Benedict reagent or other oxidation agent used in tests for reducing sugar. By converting them into a simpler monosaccharide like glucose and fructose, they do have this kind of reaction group, allowing them to be detected. The process should be carefully done because substances like ascorbic acid and polyphenol might interfere. Alright, now I'm going to tell you guys the reason why volumetric analysis is still relevant to use. Despite the use of chromatographic method, the volumetric analysis is probably way suitable for this kind of situation. Thanks to being accessible, reliable, and cost-effective, especially in a production environment that require quick and frequent testing. Volumetric analysis also require less specialized training and equipment compared to chromatographic method. The chromatographic method may not always suitable for all reducing sugar due to need for derivation or limitation.
Thank you. Moving on, we are going to talk about preservative and additives analysis. Now, what are preservatives and additives? Well, to start off, preservatives is chemicals that are used to prolong the shelf life of a product. Meanwhile, additives are chemicals that are used to enhance the taste or quality of the products. Next, we are going to take a look at an example between preservatives and additives. So how do we analyze these preservatives and additives? Well, using the most common method, that is a volumetric analysis. Now, during a volumetric analysis, they use a process that is called a titration, in which case that a solution of known concentration is reacted with the substance that is being measured. Now this titration is called acid-base titration. Another example of titration is iodometric titration. This titration uses iodine instead of acid or base. So that begs the question, why are they important? Well, they are important to enhance the taste, quality, and prolonging the shelf life of a food product. This is to ensure safety upon consumers who buy those said products.
Thanks for speaker 4. Today I will explain how volumetric analysis is used to measure alcohol content in beverages like beer, wine and spirits. This method is vital for quality control, legal compliance and consumer safety. We moving on with importance of alcohol measurement. Accurate alcohol measurement ensures beverage meet legal standards for taxation and labeling. For example, a beer label 5% of ABV must match actual content to avoid fines. It also impacts flavor and shelf life, making it critical for procedures. Next is oxidation titration method. We oxidize ethanol to acetic acid using potassium dichromate, which change color from orange to green by titrating the leftover dichromate with ferrous ammonium sulfate. We calculate the ethanol concentration. This reaction is precise and stoichiometric. And for the sample preparation, first we distill the beverage to isolate ethanol, removing sugars and flavors that could interfere. Distillation boils ethanol at 78 degrees Celsius, condensing it into a pure form for analysis. Clear spirits like vodka may skip this step. Here why use this method. Volumetric analysis is cost effective using simple lab glassware like burettes. It's faster than gas chromatography for routine checks, making it ideal for small breweries or quality control labs. And lastly is recap and application. In summary, this method relies on reversible oxidation, reaction and titration. It widely used in wineries, distilleries and laboratory labs to ensure accuracy. While advanced tools exist, this approach remains practical and trust. That's all from me.